Let us now consider the next problem. During the discussion, Compton scattering or Compton formula was mentioned. Let me now explain what Compton scattering is. Look at the figure. A photon strikes, it's something like a carom board play. A photon strikes an electron which is initially at rest. The electron is supposed to be almost free. What happens when the striker strikes the coin? The striker then flies off in one direction and the coin moves in another direction. That is the result of a collision. Here something very similar happens. The photon strikes the electron at rest. The photon gets scattered at an angle theta. The electron recoils in another direction. And now, what happens is, when the photon strikes the electron and the electron initially at rest starts moving, obviously the photon, in striking against the electron, has transferred part of its energy to the electron. The electron moves that energy. Naturally, because the photon has now lost some of its energy, the scattered photon and the incident photon do not have the same wavelength. You see, the energy of the photon is h into nu, which is h into c by lambda. When the energy changes, lambda changes. Therefore, it's very easy to understand that the scattered photon has a different wavelength. If the wavelength of the scattered photon is lambda 2 and that of the incident photon is lambda 1, lambda 2 will now be greater than lambda 1, and the difference lambda 2 minus lambda 1 is called the delta lambda, change in wavelength. And Compton, who investigated, Arthur Holly Compton, the American who investigated this phenomenon, was able to arrive at the formula delta lambda is equal to h by m naught c into 1 minus cos theta. H, of course, is Planck's constant. M naught is the mass of the electron. C is the speed of light in vacuo, and theta is the angle. Now, this h by m naught c is what we call Compton wavelength. Here, the problem is calculate h by m naught c. The formula is already given. What you have to calculate is only this quantity, and in order to calculate that quantity, you should know the value of h, the value of m naught, and the value of c. Don't you understand here? H is given, m naught is given, c is given. All we have got to do is directly substitute, and here the value of h is here, m naught is here, and c is here, and all you have got to do is get the value by direct calculation. It will be in meters. The value will be in meters. Now, that is in fact the method of analysis of the problem.